We're looking at the limit as x goes to 0 of 5x over tangent of x. My first approach, of course, plug in that 0 and see what happens. So if you plug in 0, this is 0, and the bottom is the tangent of 0. And the tangent of 0 is also, well, that's what tangent is sine over cosine, and the sine of 0 is 0, so this becomes 0 over 0. That's one of our indeterminate forms. I will apply L'Hopital's rule, which basically says just take the derivative of the top and the bottom separately. The derivative of 5x is simply 5, and the derivative of tangent of x is secant squared x. Now, I don't like thinking about secants if I don't have to. They confuse me. So I'm going to remind myself that cosine of x is 1 over secant of x, and secant of x is 1 over cosine of x. So basically, if I have a secant, I can always push it to the other side of the fraction bar and make it into a cosine. It's an algebra trick that you start to rely heavily on in calculus. There goes my pen. One moment. So this should not be an equal sign here either. That's absurd. Oh no, it's not broken. Are you broken? Come on. Catch up to where we are. Okay. So I should be looking at the limit as x goes to 0, 5 over secant squared x, which is going to equal the limit as x goes to 0, 5 times cosine squared x. Of course, if you plug in 0 to cosine, cosine of 0 is 1. 1 squared is 1. 5 times 1 is 5. So my final answer is going to be 5. So this limit equals 5.